Welcome to the Quest Review sections 4.1, 4.2, and so on. Part 1. This picture that's on the that you're looking at here, this is of Long Island Sound from Milford. And if you look closely, you can see Long Island on the horizon. As usual, I recommend doing the problems first from your sheet, and then listening to the video here, and then trying them again, or trying a problem that's like them. Okay, let's get started. In number 1 and number 2, decide whether or not the ordered pair is a solution of the system. Okay, the system is two lines, and two lines are going to do one of three things. They're either going to be parallel, in which case they don't cross and there's never a solution, or they're going to cross and there'll be one solution, like that, this spot here, or they're the same line, but we'll be talking about that later, but the same line, in which case there's an infinite number of solutions. But most of the problems we're going to have are going to have one solution. So, does the point -4, 3 work in this equation? Remember that the first part is the x, this is the y. Well, so we'll stick the -4 in for the x's and the y in for the y's. Make sure this thing works. Okay, so here we go. Y equals -13 minus 4x. So put in the -4 for the x and the 3 for the y. And we'll work it out, see if it works. Okay, so -4 times -4 is positive 16 minus 13. And yes, that does equal 3. Okay, we'll try it for the next equation. Same numbers. -4 in for x and 3 in for y. Okay, so here we get a -8. -4 times 3 is 12. Okay. 4 minus 12, or 4 plus a -12, is -8. So it works in both of those equations. So it's a solution to the system. The system is two equations. Like I said before, these two equations are going to be two different lines that cross at one point. And that point will be that point. Let's try the other one. 3 is number 2. So we're going to see if 4, -6 works in these two equations. So we have 3x plus y equals 6. So 3 times 4 plus -6 equals 6. So let's see if it works. So 12 minus 6 equals 6. Yes. So it works in that equation. Now we'll see if it works in the other one. 2 times 4 minus 3 times a -6 should equal 10. 2 times 4 is 8. -3 times a -6 is a positive 18. Does that equal a -10? No, it does not. It equals 26. So it doesn't work. It works in the top equation, but it does not work in the second equation. So it doesn't work for the system. So this one would be no. So this one's yes. The second one's no. Number 3. Solve the system of equations numerically. Numerically means with a table of values. So, let's stick something in for x. So let's, So let's start with 0. And 1, 2, 3, 4. Okay? So, we can take each of these over on the side, or you can just do it in your head. But you got to be careful. Make sure you're right. So y equals x minus 6. I don't mind people doing problems in their heads, that's fine. But I've seen a lot of silly mistakes because someone forgets about a sign or something. So you want to be sure. You got to check on yourself. Okay, so if x is 0 minus 6 equals y, then y equals negative 6. So this is negative 6. Let's do the next one, 1. When 1, I'm going to do this one in my head. If x is 1, 1 minus 6 is a negative 5. Let's do the next one, 2. If x is 2, and I'm still working on this first one, right? First equation. If x is 2, 2 minus 6 is negative 4. Now we can see a pattern developing, so we can just write the rest. Because our first column, the x's go up just by 1 each time. So if we start seeing a pattern in either of these y's, we can just follow it through. But we should check at the end. So we have negative 6. It's going down it's going up by 1. Negative 6, negative 5, negative 4, negative 3, negative 2. Okay, now let's do this one. 0, we put the 0 in for x, that the negative x disappears, and we have y equals 4. Okay, if we put 1 in for, because these are fairly easy to do in your head, see, so, but if you need to do them on paper, please do. It doesn't make sense to make a mistake. Okay, just because you want to do it in your head. Okay, so negative 1 plus 4 is 3. Okay, I mean not negative 1. 1 plus, yeah, negative 1 plus 4 is 3. Putting in a positive 1. Putting in a positive 2, it becomes a negative 2, and it becomes 2. And then putting in a 3, well, we see we've got 4, 3, 2, 1, 0. Now we're going to examine our columns. Are they getting closer together? You know? Well, 4, at first they're negative 6. You notice up here, there's negative 6 and 4. Then this one here goes up 1 to 5, and this one goes down 1 to 3. So they're getting closer together. So we're headed in the right direction. We obviously need at least another row. So I'm going to put it in. Or maybe I should have started at 1 or 2 instead. But you got to start somewhere. If you see you're a long ways off, then you might want to pick a different number to start with. So we're going to try 5. And for this, in this first one here, 5 minus 6 is a negative 1. Okay, over here we stick in 5 for this one. A negative 5 plus 4 is a negative 1. Hey, we're there. Okay, they match up there. So the solution for this system is when x is 5 for both of those two equations, y is a negative 1. So actually it means when the x and y are the same at 5, negative 1. So that's the solution. That's where the two lines cross. And that's the only place that's the solution for this system. Okay, number 4. Write a system of equations to describe the situation. Solve by graphing. Okay, here we have a sentence. One number is 2 more than another number. If you add 8 to 2 times the first number, the result is 4 times the second number. Okay, this is a translation. And we're going to get a system of equations. So that means, most likely, we're going to get 2 equations out of this. 2 lines, and we'll be able to see where the 2 lines cross. So, we've been doing these translations. This is not the first time. So let's see. One number is 2 more than another number. That's the first statement. of interest here. So one number is 2 more than another number. So we'll use x for one number, and is equals 2 more than another number. So we'll use y for another number plus 2. 2 more than a number. See, x is bigger than the other number. It's 2 more than it. Okay, now the second one, if you add 8 to 2 times the first number, the result is 4 times the second number. If you add 8 to 2 times the first number, okay, so 2 times the first number, if you add 8 to it, the result is, all right, that's our equal sign, 4 times the second number. 4 times y. Y is the second number. Okay, so now notice that the y term is on the right side of both of these equations. See, here and here. So just to make it easier for myself, I'm just going to switch sides, you know, like they do in football at the quarters. And since x equals y plus 2, well then y plus 2 must equal x. Y plus 2 equals x. You know, you do what makes life easier for yourself, as long as you know it follows the rules. Okay, and on the other side we've got 2x plus 8 equals 4y, so 4y equals 2x plus 8. Same thing. 4y equals 2x plus 8. Okay, now I've got to graph them, so I want to put them in slope-intercept form, the y equals form. So this one, I will add a negative 2 to both sides. And I think I can put it here without interfering. Y equals x minus 2. Okay, on this one, divide both sides by 4. So I get y equals 2/4 x plus, oops, 8 divided by 4 is 2. Oops, that's a funny looking 2. Okay, let's try that again. There, green. Alright, and then simplifying even further, 2/4 is 1/2. So we have y equals 1/2 x plus 2. Now I've got my intercepts, right? One's a negative 2, one's a positive 2, and then I've got my slopes. This one's got one slope, or 1 over 1, and this one has 1/2 slope. So I'm going to plot those. Okay, negative 2. See if I can get this right. Okay, so we're going to go up 1 over 1, up 1 over 1, up 1 over 1, and so on. And then the other one is, I'm going to do that a different color. The intercept is positive 2, and it goes up 1 over 2, up 1 over 2, up 1 over 2. Okay. Now I know you're thinking, hey, wait a minute, how did he get those two to cross at the right spot? Well, I did this on better graph paper before, so I know they cross at 8/6. Quite difficult to do it on this iPad. Anyhow, if you're careful with pencil and paper on graph paper, you can draw the lines and they'll cross at the appropriate spots. So anyway, you want to try this on regular graph paper, and be careful with your lines. Anyhow, good job. Number 5, solve the system of equations graphically. Again, we'll want to put them in slope-intercept form. You can graph them with the intercepts, except the first one, the intercept, you're going to be able to get one of the intercepts but not the other. You can get the y-intercept, no, the y-intercept. You can get the y-intercept but not the x. So anyway, so I'm going to put them in the y equals mx plus b form. So we have, that's a 3x minus 2y equals 14. Okay, add a negative 3x. And I get negative 2y equals negative 3x plus 14. Divide by 2, negative 2. We get y equals, now negative 3 divided by negative 2 is a positive 3/2. So we'll just put it 3/2 x, and then 14 divided by negative 2 is a negative 7. Okay, we've got our first equation. Let's graph it now. Negative 7, as close as I can get, and it goes up 3, 1, 2, 3, and over 2 to right about there. I'll do it again. 1, 2, 3, over 2, right about there. So there's our line. That's where our line's going to go. Alright, let's do the other equation. We have a negative 2x plus 3y equals negative 6. Now the only reason I'm not drawing the line in yet is because of this stylus I have is so fat. You know, and I guess apparently it works with electrostatic impulses or something, so it has to be fat. Anyhow, we'll add 2x electrostatic charge. That's what I should have said. Okay, 3y equals 2x minus 6. Is that right? Yes. Okay, so we'll divide by 3. We get y equals 2/3 x minus 2. Okay, so the other intercept is a negative 2. And then the slope is 2/3, so go up 2 over 3. 1, 2, 3. Up 2 over 3. Okay, now I'm going to okay, like before, I know that these cross at, where do they cross at? They cross at 6, 2. 6, 2. Because I graphed them on better paper. And then also I just made sure by using substitution or elimination, I forget which. But if you graph them carefully on regular paper with a pencil, they will cross right where the solution is for both of the problems. And now we take that 6 and that 2 just to make sure, we'll stick it back in the original equations. So 3x, we start with this one up here. 3x, so 3 times 6 is 18, minus 2 times 2, which is 4. 18 minus 4 is 14. So it works in that one. See, it works in this one. Okay, now let's try it in this one. And you can do this on paper, but I'm doing it in my head because I ran out of space here. Okay, so negative 2x would be negative 2 times 6, that's a negative 12, plus 3y, which is 3 times 2 is 6. So negative 12 plus a positive 6 is a negative 6. So that point does work in both of them. It is the solution to that system of equations. Number 6, solve by the substitution and elimination methods. Okay, so let's start out with the substitution method. As you remember, the substitution method is I'll get one of the equations in terms of either x or y, and then substitute that value into the other equation, because at the point where these two lines cross, which is the solution to the equation, that point's going to work in both equations. See, so that's why I can do this. So I'm going to start with the first equation. We have x plus 4y equals a negative 1. Okay, I'll add a negative 4y to both sides. That gives me x equals negative 4y minus 1. Okay, so I don't have to put it in a particular form. I just have to get it in terms of one of the variables, so this is good enough. See, so now I'll take my other equation, my negative 2x plus 5y equals 2, and I will substitute this x into that x. It's the same thing. And then this x equals this, so I substitute that in. So we have a negative not 2x, I'm putting the other thing in, negative 2 times a negative 4y minus 1, because that's what the x equals, plus 5y equals 2. See, the object of both substitution and elimination is to get rid of one of the variables, so we're only working with one. We can solve an equation if we have just one variable in it. Negative 2 times the negative 4y is 8y. Negative 2 times negative 1 is a positive 2. And it's plus 5y equals 2. Okay, 5y plus 8y is 13y plus 2 equals 2. Okay, then I'll add a negative 2 to both sides, and I get 13y equals 0. Dividing by 13, I get y equals 0. Because 0 divided by 13 is 0. These two cancel. Okay, so now we know y equals 0. We plug this into one of the equations. So we plug it into the first equation, into this x plus 4y equals negative 1 would be x plus 4 times 0 equals negative 1. Or, you see that 4 times 0 becomes 0. This becomes x equals negative 1. So we have our ordered pair is negative 1, 0. Now we plug that into the other equation just to make sure. Right? Okay, so negative 2, so I'm using this equation now, right? I'll put it right here. Negative 2 times negative 1 plus 5 times 0 equals 2. Negative 2 times negative 1 is 2. 2 equals 2. So I have found that the points negative 1, or the point negative 1, 0 works in both equations. So it's the solution for both equations. Now I had to erase everything to have room to do the elimination method, but if you want to watch that again, of course you could just back up, just rewind a little bit. Alright, so now we're going to use the elimination method. We have x plus 4y equals negative 1, and negative 2x plus 5y equals 2. So let me rewrite those up here. X plus 4y. I'm going to leave a little space, I think. Negative 2x plus 5y equals 2. So now I'm going to look at both of these equations, and I'm going to see, well, how can I fix them so that when I add them together it'll make either the x or the y disappear. So I can see, well, if I multiply the top equation by 2, it'll do that. If I multiply this by 2 and multiply this by 2, here's what I'll get. I'll get 2x plus 8y equals a negative 2. Okay, so if I add those two equations together, the positive 2x and the negative 2x cancel each other out. We have 0 here. 8 plus 5y is 13y. I don't know if you notice there's something familiar about this. And so now we have 13y equals 0. We divide both sides by 13. Again, 0 divided by 13 is 0. Anything dividing into 0 is 0. We get y equals 0. And again, we substitute our 0 back into the original equation. X plus 4 times 0 equaling negative 1 means x equals negative 1. So our ordered pair again is negative 1, 0. I'm not going to check in the other equation now because it's the same point we found before by using substitution. Naturally, it's the same point. There's only one point where both of these equations will cross, where both of them are equal at negative 1, 0. So I'm not going to bother checking. And that's that. Okay, solve using the elimination method. This one is really all set to go. We just have to add these two together. Because we can see that there's a positive y and a negative y right below it. We add them together, they become 0, and we just have x's. So we're going to have 2x plus 0, which we don't have to write in, but we are anyway, equals 16. So 2x equals 16, divide both sides by 2. 2's cancel. We get x equals 8. Alright, and then we plug that into the first equation. And we have, where we have x plus y equals 6, we'll put in the 8 here, plus y equals 6, add a negative 8, add a negative 8, and we get y equals a negative 2. So our points are x is 8 and y is a negative 2. But just to make sure, let's try it in the other equation. Make sure it works. X minus y equals 10. Okay, I mean I could have made a mistake. I've made mistakes before. 8 minus a negative 2 equals 10. Okay, so a negative of negative 2 is a positive 2. 8 plus 2 equals 10. Yes, that's true. So it works. That's our answer. Okay, a word problem. Write a system of equations to describe the situation, solved by substitution. This is a typical word problem that we're going to have with two equations like this, two linear equations. It's going to have something where there's two things that you add together and you get one number, and then there's going to be a relationship between two things. And that'll give us two equations, and then we'll just solve the system and we'll find our answer. Okay, so a National Wildlife Refuge in Michigan has 118,000 more trees than a National Wildlife Refuge in Ohio. Okay, so that's our relationship. And then the total number of trees for both is 356,000. That's the one where we add both Michigan and Ohio together and we get 356,000. So it says find the number of trees for each. So but the first thing we do is we decide what's going to be our x and what's going to be our y. So let's use the first one, Michigan. Michigan's going to be our x, Michigan's trees in the refuge, and y will be Ohio's. Okay, so let's read our first sentence. It says, National Wildlife Refuge in Michigan has 118,000 more trees than a National Wildlife Refuge in Ohio. First thing to figure out is which one's more. Michigan has 118,000 more. Okay? So it can't be Michigan plus 118,000, right? Because that would make Ohio more. It's got to be the other way. So we write X, which is Michigan, equals Ohio, whoops, and I'll make the O, equals Y plus 118,000. We won't write the 1,000 in because our answer is just going to be 1,000. Okay, then the other one is the total number of trees for both is 356,000. So that means X plus Y equals 356,000. Everything's in thousands. Okay, so we're supposed to use the substitution method. Well, notice the first equation is already in terms of X. We'll just stick that into the second equation. That X equals Y plus 118. So we'll put Y plus 118, because that's what our X equals, plus Y equals 356. Okay, then we simplify. We get 2Y equals, whoops, no, we don't get that. We get 2Y plus 118 equals 356. Add a negative 118 to both sides. And that gives us 2y equals 238. Divide by 2, divide by 2. Y equals 119. So 119,000. And what is Y? It's Ohio. So Ohio has 119,000. So Michigan, if you look up here at the beginning, 119 plus 118, right? We'll stick this Y back into this equation up at the top here. We'll stick it back into this equation. So we'll go basically 119 plus 118. There's 237 trees for Michigan. So we've got Michigan 237, Ohio 119, and also it's a good sign we see that Michigan has more trees. And now the other second equation, X plus Y equals 356. So if we add these two together, we should get 356. And we do. So now we know we're right. Okay, we've reached the end of part 1. Now it's time to move on to part 2.